Hello students. In the last class we have learned about different forms of a line. We have learned three different forms. Let us very quickly go through that. First form was a gradient point form here, this gradient point form. So when I have a gradient and one point, y minus y1 equals to m into x minus x1. This is the point. Before this we had a point gradient intercept form. If you know the gradient and you know y-intercept, we can use as y equals to mx plus c, where m is the gradient and c is the y-intercept. And form number third is the 2-point form. When we have 2 point on the line, we can use this direct formula, y minus y1 upon y2 minus y1 equals to x minus x1 upon x2 minus x1. Based on this, let us do few more questions. So yes, let us start with this question. So here there is a line, y equals to 3x minus line 9 meets the x-axis at point A. Okay, so the line meets x-axis at point A. It means we here we have to find it. This is your coordinate axis. Let us assume, and the line meets. Okay, as per the line, we can clearly see y equals to 3x minus 9. So this line is in the form of y equals to mx plus c, where m is 3, this is m, and c is minus 9. Okay, c means y-intercept is minus 9. So somewhere it is intersecting y-axis at minus 9. That's okay. And since c is 3 means positive gradient, so it will be like this. Line will be like this. It will cut x-axis at somewhere here. It will cut some x at somewhere here. Let us call it this. So the idea to find x-intercept of any line is put y equals to 0 in the line. What? For x-intercept, for x-intercept, what we will do? Put y equals to 0. Why is that? Because see, this is the point A who is in who is lying on the x-axis. So definitely we know the y coordinate will be 0. I definitely will have some x coordinate. So the y coordinate of point A will be 0. Why? Because it is lying on the x-axis. And you know any point lying on the x-axis have y coordinate as 0. Okay. After this, and since point A is lying on the line, therefore it will satisfy the condition of the line. That is why we can substitute y equals to 0 in the line to get x-intercept. If I put, so this will be 0 equals to 3x minus 9. Minus 9 will go this side upon 3. You will get x equals to 3 here. Correct? So part A, I think, okay, so that's it. Find a now then the next part. Find the equation of a line with gradient 2 by 3 that passes through point A. Okay, there is some another line who is passing through point A and gradient. We have to find this brown line. The gradient of this line, we know gradient is how much they have given us. The gradient m is 2 by 3. Yes, the gradient is 2 by 3 here. And yes, you are passing through one of the point, and point A, I think we just found it. The point A is 3 comma 0. So to find the equation, we to find the about the brown line, we know the gradient and one point. So we will apply gradient point form. To find the equation, we will apply gradient point form. Okay. And what is gradient point form? It is nothing but y minus y1 equals m into x minus x1, where x1, y1 is the point through which you are passing. Let us substitute everything. So y minus y1, y is 0 equals to m. What is the value of m? M is 2 by 3 times x minus x1. What is x1 is 3. Yes. Okay. So this is y equals to 2 by 3 times x minus 3. That's it. And as 3 is in division, we can multiply it. So it will be 3y equals to 3y equals 2x minus 6. If you open the bracket, 2 will multiply with both 1. So what we have 2x minus 3y minus 6 equals 0. And I think they have asked, write your answer in the form ax plus by plus c equals to 0. Almost it is. If you ask me, if I compare it with ax plus by plus c, let me write it once again. This is 2x plus, can I write this way? Plus of, okay, let us write this way. So this is nothing but 2x plus of minus 3 times y, similarly plus of minus 6 times minus x equals 0. And if you, this is in ax plus b y, ax plus by plus c equals to 0. Why? Because it was asking for plus sign in between, ax plus and then plus. That is why I took minus in the bracket. So yes, this is the line. By the way, you can say line as 2x minus 3y minus x equals to 0. Great. So let us take one more question. Yes, so this is the question where the line this and this intersect at point A. Okay, so there are two lines. Let us write the equation. Y equals 4x minus 7 is line number 1. Let us call it line number 1. And equation number 1. And the other equation is 2x plus 3y minus 21 equals 0. Okay, this is line number 2. They are two lines, and what we need the point of intersection. And the process to find point of intersection is you can solve simultaneously. Line number 1, equation number 2, we have to solve simultaneously. Let us use method of substitution where I will substitute y from equation number 1 into, okay, so what we are substituting? Let us substitute y, okay, from equation number 1 into equation number 2, okay. So my equation number 2 will be like this, 2x plus 3 times, in place of y, I am substituting 4x minus 7 minus 21 equals 0. And now when I substituted, I have an equation. We got an equation with just one variable. Here in this equation right now, x is the only unknown. X is the only variable. So we can find x. Let us do it. So 2x plus 12x minus 21 equals 0. So it is 12x plus 2x, 14x equal minus 21 is minus 42, and if I shift it, this will be 42. X equals to 42 upon x equals to 14. Yes, x equals to 42 upon 14, that is 3. Okay, we got x equals to 3. And okay, so we got when we solved it simultaneously, we got x equals to 3. How to get the other variable y? You can substitute this x in any of the equation, either equation number 1 or equation number 2. So I think equation number 1 is looking simple. Let us substitute. Okay, substitute x equals to 3 in equation number 1. Yeah, so when I will substitute, this will be x equals to 3. So this is y equals to 4 times 3 minus 7, 12 minus 7, it's 5. So y equals to 5. Okay, so what we got? We got x equals to 3 and y equals to 5. And when we solve two equations simultaneously, two linear equations simultaneously, we get some x and y. That x and y is nothing but the point of intersection. So the coordinate of the point of intersection. If this is point A, the coordinate will be 3, 5. Okay, great. So we are done with part A, I think. The line this intersected point A, we have the coordinate of A now. The point B has coordinate of something here. Let us say this is some point B, and let us say this is some point B. Okay, whose coordinate is minus 2, 8. Okay, find the equation of line that passes through AB. Okay, so this time we have a line which is passing through A and B. I think this one. Okay, so this time, and we have to write the equation, same thing, find the equation of this brown line. About brown line, yes, we have 2 points. So we can use 2-point form. Yeah, as per 2-point form, let us write in brown. So 2-point form, let us apply 2-point form. Okay, and what is 2-point form? This is y minus y1 upon y2 minus y1 equals x minus x1 upon x2 minus x1. Yes, where x1 y1 is the first point and x2 y2 is the second point. So let us substitute everything. Y minus y1, I am assuming A as first point, that is x1 y1, and B as second point as x2 y2. You can assume anyone. So yeah, okay, y minus y1, that is 5 upon Why? Be very careful while substituting. A is my first point and B is my second point. Again, I am making it very clear. So y minus y1 upon y2 minus y1. So 8 minus 5, I think. 8 minus 5 equals x minus x1. So x minus x1 is 3 upon x2 minus x1. Minus 2 minus 3. Minus 2 minus 3. Yeah, that's it. So what we got, I got something as y minus 5 upon 8 minus 5, 3 equals x minus 3 upon minus 2 minus 3, that is minus 5. Yes. Now we can cross multiply. Okay. So this will be something 3 into whole thing. So it will be 3x minus 9 equals minus 5y plus 25. Yeah. And then finally we can write 3x plus 5y. This is minus 9 and minus 25. Minus 34. It will be minus 34 equals 0. Now I think this is the required form. Ax plus by plus c equals to 0. Okay. So yes, this is the equation. If you ask me ABC, I will report as A equals to 3, B equals to 5, and C equals to minus 34. Yeah, that's it. So here we solve this example 9. That's it. Okay. Yes, so this is just the discussion of that part. Yeah. So we are good to go about finding equation of lines. Let us do the next topic, that is uh, what about two parallel line and two perpendicular line? That we have to understand that. Okay. Here, let us assume line 1 and line 2 is parallel. That is why I am using this arrow. And the gradient, what is gradient? Gradient gives you an idea about slope of the line or inclination with the x-axis. So can I say the gradient of line L1, let us call it L1, L1, sorry, yeah, L1, and this is line L2. So do you think the inclination of line 1 and inclination of line 2, or slope of line 1 and slope of line 2, that is gradient of line 1 and gradient of line 2 will be same? Just by visualization, we can use this property as if two lines are parallel, their gradient are equal. So I am writing this as a result. If L1 is parallel to L2, then the gradient of those two lines will be equal. Okay. M1 equals M2. Okay. This is about L1 like this. Next, what about if two lines are perpendicular like this? Let us say this is line 1, L1, having gradient as M1. Okay. And there is some another line who is perpendicular to line L2. There is some line L2 who is perpendicular to line L2. Line 1 and line 2 are perpendicular to each other. And let us say the gradient of line L2 is, we are representing as M2. So property says, as per the property, the product of, if two lines are perpendicular, let us write the same as result as, if L1 is perpendicular to L2, therefore the product of their gradient will be minus 1. This is, we are using it as a result. M1 into M2 equals minus 1. Okay. So this is the takeaway. M1 into M2 equals to minus 1. Okay. If two lines are parallel, we have their gradient as same. If two lines are perpendicular, their gradient will be, the product of their gradient will be minus 1. Yes. But here, important shortcut. We will understand important shortcut. Okay, important shortcut here. Let us say this is line L1. L1 is having gradient as, let us say L1 has gradient as 2 by 3. How much? Let us write this way. The gradient of line L1 is 2 by 3. And this is line L2 who is perpendicular to this. This is L1 and this is line L2. L2. The gradient of line L1 is 2 by 3. So we have to find the gradient of line L2 directly or shortcut wise. Definitely, we can use this property, M1 into M2 equals to minus 1. Using this property, you will get the answer. But the same result we have to note as a shortcut, important shortcut. Step 1, The step one to find the slope, change sign. Change the sign. Change the sign means कि if m1 is 2 by 3, it is positive, so m2 will be some negative. That way. Whenever m1 will be positive, m2 will be negative, and m2 is negative, m1 will be positive. And step 2 we have, step 2 is do reciprocal. Reciprocal, yes. You know, reciprocal of 2 by 3 is 3 by 2, and reciprocal of 5 is 1 by 5, like that way. So what is the reciprocal of 2 by 3? It is 3 by 2 only. It is 3 by 2. Okay, so directly shortcut, if gradient is 2 by 3, the second gradient will be minus 3 by 2. Same thing we can find by using this property also. Let me show you the same thing by using this. We know m1 into m2. You know, m1 into m2 equals to minus 1. What about m1? M1 is 2 by 3. Yeah. So 2 by 3 times m2 equals minus 1. What about m2? M2 is minus 1 into 3, that is minus of 3 by 2. Did I got the same one? Yes. Okay. So what we learned here, if two lines are parallel, their gradient will be same, and if two lines are perpendicular, the product of the gradient will be minus 1, and shortcut wise, change the sign and do reciprocal. You will get the gradient. Let us do this question now. A line is parallel to a line is parallel to this line. Okay, there is a line given. That is equation is 6x plus 3y minus 2 equals 0. That's okay, and passes through it. Okay, let us rearrange it in y equals to mx plus c form. The equation of, okay, the line is parallel to this. There is some another line. There is some another line who is parallel to this. Okay, and passes through a point whose called, that is called, let us call it a, that is called 0 comma 3. Okay, and these two lines are parallel. These two lines are parallel, by the way. We have to find this equation of this blue line, the bottom blue line. Okay, a line is parallel to this line. So our line is parallel to 6x plus 3y minus 2 equals to 0, and our line is passing through 0 comma 3. We have to find the equation of the line. Just now we learned, if we have gradient and one point, we can use gradient point form. To find the equation of a line, we need gradient and a point. And since these two lines are parallel, they will have same gradient. Then what is the gradient of this line, the top line or line L1? We can find like this. This is, can I write this way directly? 3y equals minus 6x plus 2. Yes. So what about y now? Y is 3 is in product, it will go in division. So it will be like this, 6x plus 2 whole upon 3. And then you can separate it. So it will be nothing but y equals to minus 6 minus 2x and plus 2 by 3. Yes. So what is the gradient? Now you can see this line is in the y equals to mx plus c. The mx plus c. So what is your gradient, by the way? Minus 2. Since your gradient is minus 2, so this line gradient will also be m equals to minus 2. Why? Because these two lines are parallel. And now definitely we can find the equation. To find the equation, now we have gradient and we have what we have? A point. So let us use gradient point form. Which form I am using? I am using gradient point form, and that is nothing but y minus y1 equals m into x minus x1. Correct. Where x1 y1 is the point through which line is passing. So it is y minus 3 equals, in place of m I will substitute minus 2 into x minus 0. Yeah. So this is y minus 3 equals minus 2x, and anything multiplied by 0 is 0 only. What about this? This is, let us bring it this left side. So this is 2x plus of y minus 3 equals 0. That's it. So we have the equation of our required line. This is the equation of required line. In this question, what property we use? We just use the idea, if two lines are parallel, their gradient will be same. Okay. Work out whether these two lines are parallel, perpendicular, or neither. Okay, let us understand case 1. Case 1 is 3y minus y, okay, where this is 3. Okay, let me write it. About line 1, this is 3x minus y minus 2 equals 0. This is my line 1 here. Can I write this way? Let us use in y equals to mx plus c, so that we can directly get the gradient. Here my gradient is y equals 3x minus 2. So your gradient m1 is, what about m1? M1 is 3. Yes. Okay. Let us find the gradient of line 2. That is, this is x plus 3y minus 6 equals 0. So 3y is how much? 3y is minus x plus 6, and y is 3 will go in the division and you can separate it. So it will be minus 1 by 3 x, and then 3 plus 2. Yeah, that's it. So what about m2? M2 is minus 1 by 3. And just now we learned, see, m1 is 3. Are they parallel? Are they parallel? If they are parallel, their gradient must be same. So, but the gradient is not same, so they are not parallel for sure. Are they perpendicular? What shortcut we learned? We learned if I do opposite and reciprocal, I will get m2. So yes, they are perpendicular. Line 1 is perpendicular to line 2. And you can prove this way also. If you find m1 into m2, let us find m1 into m2. So this is 3 into minus 1 by 3, that is coming as minus 1. M1 into M2 equals to minus 1. And this property, if M1 into M2 equals to minus 1, therefore, this happens when two lines are perpendicular. Therefore, let us write L1, line L1 is perpendicular to line L2. We can write like this. Okay. Let us do the second question, part B. In part B, what was the question? Yes, let us use white color and see how it is going. Part B. So here y equals to 1 by 2x, and it is very clear m1 is the line m1 is 1 by 2. It is directly y equals to mx plus c. If I write plus 0, so it is very clear that y m1 is this. What about m2? The second line is 2x minus, the second line, if I say it is 2x minus y plus 4 equals 0. If I make y as subject, it will be 2x plus 4. What about m2? M2 is 2. What do you think? Are they same? No. So the lines are not parallel. Are they perpendicular one, like m1 into m2 equals to minus 1? Will you get, if you multiply 2 into 1 by 2 into 2, will you get minus 1? No, we will get 1 only. So they are not perpendicular also. So here, neither case. Okay, neither parallel nor perpendicular. Yes, line 2 is neither parallel nor not perpendicular. Okay, we have one more question. A line is perpendicular to line this. I think, okay, this is some line, and the equation of this line, let us write the equation as 2y minus x minus 8 equals 0. Okay, a line is perpendicular. So our line is perpendicular to this line. Okay, let us call this as line L1 and this line as L2. So we are interested in line L2, who is perpendicular to line 1 and passing through 5 comma minus 7. Okay, that's it. Find the equation of line. Okay, so we have to find equation of line L2. Line L, since these two lines are perpendicular, if I have from the equation, definitely I can get equation gradient of line L1, and since these two lines are perpendicular, so I will get gradient of line L2. Let us do that. This is 2y equals x plus 8. Yeah. What about y? Y is 1 by 2x plus of 4. Yes. What about gradient? So gradient is 1 by 2. If I compare it with y equals to mx plus c, I will get y m as 1 by 2. Since the gradient of line m1, gradient of line L1 is 1 by 2. What about gradient of line L2? As per shortcut, we know m2 will be, do the change the sign. So it is positive, so it will be negative, and do the reciprocal. So it will be minus 2. The reciprocal of 1 by 2 is minus 2. Okay, and now about line L2, we have gradient and we have 1 point. Let us use y minus y1, gradient point form. Y minus y1 equals m into x minus x1. Yes, so it is y minus y1. Y1 is minus 7 equals m into x minus x1. X minus x1. X1 is 5. Yes. So what we got it as, y plus 7 equals minus 2x plus 10. Okay, let us see it this way. 2x plus y plus 7 minus 10 minus 3 equals 0. Yes, this is the equation of line L2. Here we used that property where if line L1 is two lines are perpendicular, the product of their gradient is minus 1. Okay, so this is about parallel and perpendicular line. Parallel and perpendicular line. Let us do the last part of this topic, that is finding length and area. Length and area of a line segment. By the way, again I will say derivation is not required, but let us understand it as a question only. So if AB is a line segment whose endpoints are given, can you get me the length of AB? Length of line segment, we have a formula like this. The formula goes like length of line AB will be square root of x2 minus x1 whole square plus of y2 minus y1 whole square. Let us just see, it is very how we got this length. The formula as this one. So what about this? Let us say the coordinate point A be x1 y1 and B be x2 y2. So yes, this is quite an understanding of your coordinate axis. Since point P and point B are at the same level, so x coordinate will be same. So whatever x coordinate of point B, the same x coordinate of point P. And about y coordinate, point A and point P are at the same height. Therefore, they will have same y coordinate. So this is y1. The coordinate of y coordinate of A is y1. So y coordinate of point P will be y1 also. Now, can you get me the difference AP? So if you ask me the difference AP, this is x2 minus x1. That's it. The difference AP is nothing but yes, it is x2 minus x1. And what about the length distance BP? BP is, since the x coordinate is same, just the change of y coordinate, so it will be y2 minus y1. Okay. And now triangle APB is a right angled triangle. We can apply Pythagoras. As per Pythagoras, what we are doing in a right angled triangle, in a right angled triangle APB, we can apply Pythagoras, and that is what is it? So AB square will be what we got. We got AB square is equal to AP square plus of BP square. Yes, that way. What is AP square? AP is x2 minus x1, so it will be x2 minus x1 whole square plus of BP. BP is y2 minus y1 whole square. BP is y2 minus y1, so BP square will be y2 minus y1 whole square. Yeah, correct. This is AB square. And what about AB then? After this, what about AB? We find it AB. AB is nothing but to remove this square, it will be plus minus square root. Plus minus square root. But since AB is representing a length, so length never becomes negative. So I will write only plus. So it is positive square root of the same thing. What? X2 minus x1 whole square plus y2 minus y1 whole square. Yeah. So this is the distance formula, by the way. We use this to find the length of the line segment or distance of a line segment. AB as x2 minus x1 whole square plus of y2 minus y1 whole square. That's it. Let us do a question based on this. So yeah, find the distance between this and this. Okay. So here we have a line like this, where let us call this point as A and this point as B. Always try to draw the line to have a graphical understanding. Coordinate of A is 2 comma 3. Okay, this is 2 comma 3. And what about coordinate of B is 5 comma 7. Okay, and we need distance between them. So distance AB will be, we just learned the distance as per distance formula. The formula is x2 minus x1 whole square plus y2 minus y1 whole square, and that will give me, this is equals to nothing but, let us substitute everything. I am assuming A as the first point, that is x1 y1, and B as second point, that is x2 y2. So x2 minus x1. So 5 minus 2 whole square, 5 minus 2 whole square plus of y2 minus y1, 7 minus 3 whole square. Yes, correct. So it is equals to root of 5 minus 2, 3 whole square, 9,
and plus of 7 minus 3, 4 square 16. 16 plus 9 root 25, and root 25 is nothing but 5. So what we got, distance AB is nothing but 5. Okay, yeah. So this is we use distance formula only here. And what is distance formula? Distance formula is nothing but root of x2 minus x1 whole square plus of y2 minus y1 whole square. Let us call, in place of L I am calling D. D means distance of line AB. Okay, let us use this one. What is the question? The straight line L1 with the equation this. Okay, line 1 is having equation y equals to, okay, let me write 4x minus y equals to 0. That is, okay, this is my line L1. So line 1. The straight line L2 with the equation. There is another line L2 and they intersect at point E. Okay, this is, what is this? 2x plus 3y equals 21. Can I write this way? I have just shifted minus 21 to the right side. And okay, they intersect at point A. These two lines intersect at point A. Let us find the point of intersection. In the last question, we have used method of substitution. Let us use, this time, let us use another method to find point of intersection, or solving two linear equations simultaneously as uh, equating the coefficient, or elimination method. So in equation number one, my the coefficient of y is -1, and equation number 2, my coefficient of y is +3. Let us equate variable y. So what equate mean, I will not make equal, I will make opposite. Since here the coefficient of y is +3, I will try to bring here -3. So for that we have to multiply equation number 1 by how much? 3, I think. Let us do that. So it will be 4x minus 3, when I multiply by 3, it will get multiplied by the whole. So 4 3 is 12x minus 3y equals to 3 into 0, that is 0 only. Let us write the same thing, equation number 2 as same thing. So this is 2x plus 3y equals 21. And now what is this? Minus 3y plus 3y you can cancel. So 12x plus 2x is 14x. 14x equals to 21. Okay. Is it 21 only? For, let us check. 14x, x equals to 21 by 14, by the way. Okay. 1 by 14. Am I correct till now? 4x minus y equals to 0. 2x plus 3y minus 21 equals to 0. 12x minus 3y equals 0. And then 2x plus 3y equals 21. That's okay. 12x plus 14x equals to 21. Yeah. So x is this much. How to find y? For y, let us put x equals to 21 by 14 in equation number 1. Let us do that. So this will be y is equals to 4x minus y equals to 0. So y equals to 4x. Y equals to 4 times x. 21 by 14. And 2, I think we can cancel. 2 2 ja, 2 7 ja, and 7 3 ja. Okay, so y equals to 3. Y equals to 3 2 ja, 6. Yes. So the point of intersection of this line is, these two lines is this one. This is L1, this is L2. And yes, point of intersection is 21 by 14. Let us call this point as point A, and this is 21 by 14 comma 6. Yeah, the point of intersection. We know if we solve two equations, the solution x and y are the coordinate of point of intersection. Okay, so part A is done, I think, till now. Yes. What about part B? For part B, work out the area of triangle AOB, where B is the point where L2 meets x-axis. Okay, so I have to find point B, and B is the point where L2 meets x-axis. So x-intercept, we have to find x-intercept of line L2. Okay, to find x-intercept, what we do, we put y as 0, y equals to 0. In L2, if I put y equals to 0, it will be nothing but 2x equals to 21, x equals to 21 by 2. Yes. So now we have a situation like this. Now we have a line. Okay, let us draw a coordinate axis like this way. So line L1 and L2. L2 is intersecting y x-axis at 21 by 2. That is okay here. This is point B, by the way, and this is 21 by 2. What about O is origin, and what is point A? Point A is 21 by 14 comma 6. 21 by 2 is 10.5. 14 2, 10, 14, okay, 1.5. There is some point A which is here. The point A is somewhere here. We have the coordinate 21 by 14, comma 6. We have to find area of this triangle.
Yes, is it till now? Are we correct? B is the point where L2 meets X axis. So B is 21 by 2. That's it. O is origin. AOB. A is 21 by 14, comma 6. Yes. We have to find area of this triangle.
Do we have height of this triangle? Basically, yes. So height of this triangle is nothing but this one. That is 6. The y coordinate of point A will be the height one. So we can use to find area. We can use half into base into height. So therefore, area of triangle AOB. AOB is nothing but half into base. What is base? The length of base is 21 by 2 into height. What is height? Height is 6. Okay. 2, 3 ja, we can cancel like this. 21 by 2, yes, 10. This is something 10.5 times 3, 31.5, yes. 31.5 unit square. We can write 31.5 unit square is the area.
So we know area of a triangle is half into base into height.
That is what we have used here. So this last topic was about finding length of a line segment and area of a triangle. Okay. Yes, thank you. If you are liking video, please consider liking the video and subscribing to the channel. Thank you.